In this lesson, we are going to look at the different types of inorganic reactions. Specifically, you will learn to classify a reaction as a combination, decomposition, single replacement, double replacement, or combustion. We can also look and determine whether or not a reaction is a redox reaction. This is a separate designation from being identified as combination, decomposition, etc. A reaction can be a combination and a redox reaction, or it could be, say, a double replacement and not be a redox reaction. Those two designations are separate. We will also look at how to predict the products of a combustion reaction. When we look at a mixture, sometimes we see very obvious evidence that a reaction has occurred. We might see the formation of a precipitate, which is a solid that precipitates out of solution, flames or heat, changes in colors, bubbles, and sometimes we don't see anything at all. But the lack of any of these symbols doesn't necessarily indicate that nothing happened. It just means that the reaction happened without producing a visible product. Now we're going to look at several types of reactions. The first of which is a combination reaction. In this case, two or more molecules combine to form a larger molecule. In this example, we have 2 sodium plus chlorine, giving us 2 NaCl. In this case, we actually started from elements, but those could just as easily have been molecules or compounds. The next type of reaction is a decomposition reaction. In this type of reaction, we see that molecules break apart into 2 or more smaller molecules. This is the opposite of the combination reaction we saw on the previous page. In this case, the compound is breaking down into smaller pieces. Here we get a compound and an element. This reaction shows the decomposition of hydrogen peroxide. If you've ever noticed, the hydrogen peroxide in your bathroom cabinet is in a brown bottle and is best stored in a dark area, because the light will catalyze the breakdown of the hydrogen peroxide into water and oxygen. Chances are, if you have a very old bottle of hydrogen peroxide, it's mainly water with only a small amount of peroxide left. The next type of reaction is a combustion reaction. We mentioned combustion reactions when we first talked about alkanes. Because alkanes don't have any functional groups, they're very unreactive. However, their main purpose is for combustion, and when they burn, they produce energy. And so when we have a combustion reaction, we see an organic compound plus oxygen to form CO2 and water. Note that the reactant, oxygen, is always required, and we also always will produce CO2 and water in every combustion reaction. The next type of reaction is a single displacement reaction. In these reactions, which are also known as single replacement, a free atom replaces an atom in a compound. Our example here shows HCl reacting with zinc. Zinc displaces the hydrogen and forms ZnCl2 plus H2. Notice that the zinc bumped the H out of the HCl compound and took its place. A common question from students is, how do we know which one is going to get replaced? Well, notice that zinc is a metal and it can only form a cation, so it can only replace a cation in the other compound. H is also a cation here, with Cl being the anion. Therefore, the zinc must replace the hydrogen if it's going to replace anything. Similar to the single displacement, there is also double displacement. In this case, cations swap their anion partners. Notice that Ag and Na are the cations, so they would have a positively charged ion. Nitrate and Cl- are our anions. In the products, we see that the Ag is now partnered with the Cl, and Na is now partnered with NO3. This is the only way that a swap can happen. Remember that we cannot have 2 anions or 2 cations paired together. We must have 1 cation and 1 anion. Let's look at some examples to get some practice identifying reaction types. What do you think the reaction type is for the first reaction? Notice that we start with a compound NH4Cl and it breaks down into NH3 and HCl. It breaks into more species and smaller species. Therefore, this is a decomposition reaction. What about reaction 2? In this case, we have two ionic compounds, so they each have a cation and an anion. And when we compare the reactants to the products, we notice that they have swapped partners, so this is a double displacement. On to reaction number 3. In this case, we start with two elements and form a compound. Therefore, this is a combination reaction, and sometimes you'll see it called a synthesis reaction. What about number 4? In this one, we see that we start with an element and an ionic compound, and we end with an element and an ionic compound. But the identity of the free element versus the cation in the compound has changed because they've swapped places. Therefore, this is a single displacement. Number 5. We have two compounds that come together to form one larger compound, so this is also a combination reaction. Notice that in this case we started with two compounds. In number 3, which was also a combination reaction, we started with two elements. Either is fine. The goal of a combination reaction is to take smaller things and combine them into a larger molecule. And number 6. We have an organic compound plus oxygen yielding CO2 and water. Therefore, this is a combustion reaction. As you're learning to identify the reaction types, what you need to do is learn to look at the patterns of behavior. For example, with a combustion reaction, we always see O2 as a reactant and CO2 and H2O as products. So look for those patterns that help us identify the reaction type.